Okay, so today for section 6.4, we are just going to be comparing all the methods that we have already learned. So it says comparing methods to solving systems, so nothing will be new. We are going to talk about graphing, substitution, and elimination. And it says systems of equations can be solved by these three methods. However, there are situations where one method may be more sophisticated than another, or in other words, may make a little bit more sense, may create less work for yourself, may make the solving the problem a little bit easier for you. So we're going to solve the following systems by using graphing, substitution, or elimination, but we're only going to use each method once. The important reason to understand how to use each method is because sometimes you might be asked to use a specific method. So you have to be able to use them all. We don't want you to focus on just understanding one of them because all of them are going to be useful. So the way you're going to kind of decide, so I've got all of these systems. Graphing, the first one listed, graphing is always going to work. You can always turn these equations into slope-intercept form. You can always graph two lines, and you can always look for that intersection point. The hard thing is sometimes it's hard to find that intersection point, especially if you haven't drawn your graph nicely. Sometimes it takes time to get your equations into slope-intercept form. So graphing is kind of I think of graphing as almost like a last resort option, or like the not ideal option, or it could also be an option if you forget how to do one of the other methods. So you guys can all, like, we can either use substitution or elimination for every problem, but then if you ever forgot how to do that, then you could always put these in slope-intercept form and graph them to check. Now, so that's kind of my spiel about graphing. When talking about substitution, you're going to want to look for, make a little note, I'll take some notes up at the top. So if we're going to choose substitution, I am going to look for at least one variable has a coefficient of 1. Because remember, you want to get a variable by itself if you're going to use substitution. So that's going to be the easiest way to use substitution, is if you already have a variable with a coefficient of 1. And so the best time to use elimination is if you have some equations in standard form, or all variables have coefficients greater than 1. Okay? So let's go through. We have to use each method one time. So let's go through and pick. Like I said, graphing is going to kind of be the one that is almost like a fallback method because you can always convert to slope-intercept form. So I'm going to look at this first one, and I'm going to notice that both this x and the y have 1 as their coefficient. So I am going to choose to solve this using substitution. Okay? Then I'm just going to come over here, choose which variable I'm going to solve for. I'm definitely going to take it from this first equation. I'm going to choose x. So I'm going to take my x minus y equal to -2. I'm going to add my y over so that x is by itself. So now I have x equals y minus 2. So now I have an x equals equation. So I can throw all this in parentheses and plug it in for my x in my other equation. Let me unhighlight that. So all those that parenthesis is going to end up right there. So now I'm going to say that 7 times y minus 2 plus 2y equals negative 5. I'll distribute. So now 7y minus 14 plus 2y equals negative 5. Combine your like terms, and you end up with 7y plus 2y, so 9y minus 14 equals negative 5. Add your 14 over. So 9y equals 9. And then divide by 9. So y equals 1. Okay? Now that y equals 1, I'm just going to plug that into an equation. I'm just going to use this one right here, so it's already solved for x. So x equals 1, plugged in for y, minus 2, so x equals negative 1. So then our solution over here in this box is going to be negative 1, comma 1. Okay? Alright, so let's move on to system B. We can no longer use substitution, so we have to choose graphing or elimination. Now looking at this, I don't have any matching coefficients, and they're both in standard form, meaning x and y are on the same side. Actually, let me write standard form for you. Standard form, write it up here. Standard form is that ax plus by equals c. Okay, so both of these are in that format, so elimination is going to be a good method for us to use. So I'm going to use elimination. In order to use elimination, I need matching coefficients. I have an 8 and a 3 here, not ideal. 5 and 4 here, also not necessarily ideal, but sorry, I can get either set of these to match. It just depends on which one I want to do. I'll do my y's, and so the smallest number that I can get both of these to is 20. I'm going to have to multiply this whole top equation by 4, and I'll have to multiply the whole bottom equation by 5. So that becomes, when I distribute the 4 to everything and the 5 to everything down here, now I have 32x plus 20y equals negative 52. I have 15x plus 20y equals 50. And now I can see my matching coefficients. So you can always choose the number from the other coefficient as what you're multiplying by, and that will always work out. Sometimes you can find smaller numbers, but that one will always work. And so then, notice they have the same sign. So same sign equals subtract. Okay? If your coefficients have the same sign, you subtract. So that means I'm going to subtract both equations. So 32 minus 15 is 17x. 20 minus 20 is 0. And then negative 52 minus 50 is negative 102. So 17x equals negative 102. Divide by 17. And x equals negative 6. And so then I can plug that in for any equation. I'll just come up and grab the first equation. So none of them are very pretty. So that's my x. Plug it in for that variable. So 8 times negative 6 plus 5y equals negative 13. 8 times negative 6 will give me negative 48 plus 5y equals negative 13. add my 48 over, and 5y will equal 35. Divide by 5, and y will equal 7. So now my final solution is -6, 7. Okay? All right, now we have to use graphing because we've already used the other two. We don't have an option. Notice this problem would be nice doing either. We could do substitution because you have that y. You could also do elimination because it would be easy to get this 2 to look like that 4. So you could use other methods, but since this worksheet specifically said do each method, we're going to have to graph here. So we need to put these both in slope-intercept form, so y equals mx plus b. Okay? So I'll start with the top one. 4x minus 3y equals 18. Subtract my 4x over, because you're trying to get, trying to get y by itself. So I subtracted those. So now I have negative 3y equals negative 4x plus 18. Still trying to get y by itself. So I'm going to divide by negative 3. Divide everything by negative 3. So then I end up with y equals 4/3 x minus 6. Y is now by itself, so that one's done. Then I will do my other equation as well. So 2x plus y equals 4. Subtract your 2x. Cancel out. Y equals negative 2x plus 4. And so now, okay, y is by itself here too. Remember, that was your goal. Get y by itself. All right, so now I've got my two equations. Got this red one, this green one. And we're going to graph them and look for that intersection point. I'm just going to draw a graph to the best of my ability here. Get some straight lines. Okay, so notice my lines can't be perfect, and that's why this is going to be hard to tell exactly where they're intersecting, and that's why graphing is one of the less useful methods. So this, I'm going to do this one first to make sure you start down at -6. So 1, 2, 3, 4, 5, 6, and then I'm going to go up 4, right 3. So 1, 2, 3, 4, 1, 1, 2, 3, 1, 2, 3, 4, over 1, 2, 3. And I'm just going to leave those 2 points for now, or 3 points for now. I'll also do my green line. So the green one starts at +4 and goes down to right 1. So +1, 2, 3, 4. And go down to right 1, down to right 1, down to right 1. So there is my intersection there. So remember with graphing, I know it's been a while, but you want to plot a bunch of points so that you can really see where the intersection is. Because if I had just drawn in my lines, it probably wouldn't be as easy to see, because it's still kind of hard to tell, even with how many points I did, but my lines are so squiggly that it's very hard to tell. So it is this point in the middle here, which is at 3, -2. So my solution to my system is 3, comma, negative 2. And if you ever couldn't tell, but you were told you had to graph, you could always be graphing these and then checking it with substitution or elimination just to double check your work. Okay, so it says, what is your reasoning for picking the method in each system? That's kind of what I've talked about through the whole, the entire notes video. So if you wanted to test yourself, you could explain a little bit on the back of these notes. If you did not understand why I chose each method from the video, make sure you're going to ask that in class tomorrow.